Hello everyone, my name is Kim. Welcome back to my channel. Today we're gonna solve another legal question. Valid parentheses. Given a string containing just characters of this opening bracket, determine if the input string is valid. There is two conditions where it is valid. Open bracket must be closed by the same types of brackets. So look at the sum of the example. Brown bracket has to be closed by a brown bracket, which is good. This three is relatively obvious. However, the brown bracket but is closed by the square one won't be that obvious. Now probably we're gonna need another example just to see a bit complicated case. Okay. That one should be 4 because ideally this has to be, there's an open, but also there has to be a close. So if it is valid, in this case, the brown bracket has to be open and closed by a square bracket, because this one is one big brown, but then the square is not closing up all the time. Or even that, it will be valid if the browse is like this. Okay, so what is the strategy that we need to use? So for this question, there's two strategies that we can remember. First is using the stack to drag the opening bracket. Secondly, we need to use a hash map where we do actually store the closing bracket so that we can match it to the opening bracket. So anything that is closed, we need to map it with the opening one. And then because we use a stack to track the opening bracket, so let's use an example as a valid. Maybe an easy example so we can learn about the valid case. Okay, so right here we need to use a stack in order to track the opening bracket. So the first one, if it's opening, then we add to the stack. Next one, if it's closed, we kind of identify whether the first value in the stack is actually matching this closing bracket. So because this is the brown bracket, so we're gonna pop it. It's matching, then it say valid. Okay, then we're gonna move to the next one. This is a square bracket because it's an open. We're gonna add this to the stack. That's good. Now we track the closing bracket. Does it matching with this square bracket? It's matched, so we can pop it. Okay, so this one opening, gonna add it to our stack, and it's closing, it matching with this stack. Okay, so this is a valid case. Gonna return true. Let's look at some of the invalid case. We're gonna have an example. Okay, so since we have an opening bracket, we're gonna add it to the stack. Next one, we have it. We're gonna add to the stack as well. Now we check the closing. This is the closing bracket, right? So we're gonna check the first on the stack, which is square bracket, but it's not the closing of this one. So right away we can return 4. And when do we also return 4? Is when the stack is none. Because we don't have a stack, so we have no way to track it backward. Okay, so that is good. Now we move to the code base. We're gonna create a stack. We're just gonna create a mapping section right here. We're gonna map the closing and the opening. Just gonna copy all of this so I can easier to rewrite it. Now we're gonna loop for characters in S. We also need to verify these characters in the mapping with a loop tool. If this characters is in mapping, like we mentioned earlier, if the opening parenthesis, then we're gonna append into the stack. If so, we have a valid up to condition is the stack has to be valid. So if not stack or stack dot top, the first value in the stack, the top value in the stack doesn't matching the mapping. Characters, then right away we return false. Else, then we can add it to. Okay, then we're gonna return if it's not stack, when the stack is empty. Okay, so we'll see. Hit run. Here is some of the wrong key. Okay, so this is wrong. The mapping is not accurate, so let's hit run again. Okay, accepted. 62. Submit. What is the space and time complexity? So the space complexity of this question will be O of n, because in the worst case scenario, the stack can store all the opening bracket. And the time complexity will also be O of n because we need to iterate each character once. And for each operation, we also have push and pop. So we just take a constant time as well. So time and space complexity is O of n. Awesome. Well, thank you guys. We'll see you on the next video. Bye.